Dear students, you will study about the Newton's second law of motion. In previous section, we have learnt about the situations and states of object when no external force is acting upon it. We have also learned that when an external force is exerted on an object, it shows acceleration. The second law of motion relates its force applied to the acceleration of the body. But before we study Newton's second law of motion, it is important to first study about the momentum of the body. Try to understand with the help of this example. Suppose a cricket ball is rolling along the ground. Some force will be required to stop it. If it is coming with a higher velocity, a greater force is required to stop it. Again, if a cricket ball and an iron ball of the same size are made to roll with equal velocities, obviously much greater force is required to stop the iron ball than the cricket ball. It means the force required to stop a moving body is proportional to its mass and its velocity. The product of this mass and velocity is called the momentum of the body. It means the momentum of a body is the measure of quantity of motion contained in it. Its SI unit is kg meter per second, and the direction of momentum is along the direction of velocity. We know that the linear momentum of a fast moving body is greater than the slow moving body when masses of both the bodies are equal. Now, Newton's second law of motion, it states that the rate of change of momentum is directly proportional to the applied force, and the changes takes place in the direction of the applied force. We know larger is the force, greater is the rate of change of momentum. Since mass of the body remains constant for a given body, then the momentum can change only due to the change in velocity. That is, acceleration produced in a body is proportional to the external force acting upon a body. So we can also say that the acceleration produced in a body is directly proportional to the external force acting upon the body, or in other words we can say acceleration is also always associated with force. Now you see here, if a mass u and v the initial and final velocity of the body and t with the time, then f is directly proportional to final momentum minus initial momentum upon time. That is mv minus mu upon t. Finally you will get f is equal to ma. Means f is equal to ma. So it is the product of mass and acceleration. If f is, the SI unit of force is Newton. You can also define 1 Newton. If m is equal to 1 kg and a is equal to 1 meter per second square, then f is said to be 1 Newton. Or we can say that 1 Newton is that force which produces an acceleration of 1 meter per second square in a body of mass 1 kg. Now, there are some applications of the Newton's laws of motion. Taking a catch. In cricket, refer the figure, observe a fielder taking a catch. He moves his arms backward in the direction of ball while taking the catch. By doing so, he increases the time and decreases the rate of change of momentum. So thus the ball exerts a small force on the fielder does not hurt his hands. If the fielder takes the catch without moving the arms backward, then the entire momentum of the ball will be reduced to zero very instantly, which will cause a larger rate of momentum, and the ball will exert a greater force. Similarly, in high jump activities, the athletes are made to fall on a soft sandy floor, which decreases the rate of change of momentum by decreasing the time taken. So in this case also the rate of change of momentum is small The force due to the fall is small, thereby the athlete is not hurt. So now in this case also the another is the shockers are provided in vehicles. It is only by doing so we decrease the rate of change of momentum, which also reduces the dangerous shocks when vehicles move over uneven roads and speed breakers. So now you will discuss the Newton's third law of motion in the next lecture. Thank you and have